Good morning. Today we start Chapter 2 Boolean Algebra. In algebra, it's a branch of mathematics where we deal with numbers which are integers, positive, negative, real numbers, including 0. But in Boolean Algebra, we deal with only two numbers, 0 and 1. Now, the question is why we have to learn Boolean Algebra in computer science? We know that computers normally use binary numbers. You have studied everything regarding conversions between binary numbers, decimal numbers last year in the first year in chapter 3. Now, as a computer is a digital device, all the digital instruments or devices work with binary numbers. You know it for processing of data, whatever the type of the data, text, numbers, whatever. Now, Boolean algebra deals with binary number system. So we have to study Boolean algebra in computer science. You know that it is very useful in designing logic circuits. In digital electronics, there are circuits called logic circuits, which are the building blocks of almost every digital device. Now, these logic circuits used by the processors of the computer system to analyze those and to design, we require the principles of Boolean algebra. Logic gates that are used to build the circuits of different types of uh, devices to perform the necessary arithmetic operations also use Boolean algebra. So, in the implementation, designing of logical circuits and the analysis of the expressions or the circuits, we require Boolean algebra. There is some history for this Boolean algebra. Long ago in BC, Aristotle, he constructed the complete system of formal logic. Then, after so many years, George Boole, a famous British mathematician, he has written a revolutionary paper called An Investigation of the Laws of Thought, where he published the principles of this Boolean algebra, the formal logic. This work led to the development of the new system, which later called Boolean algebra. So the name Boolean algebra came from the work of George Boole, that was in 1854. Later, in 1938, another scientist, Claude Shannon, he has written a paper titled A Symbolic Analysis of Relay Switching Circuits. He was working on relay switching circuits, a kind of logical circuits only. So he used the principles of Boolean algebra to study these relay switching circuits. That is why the name of algebra, this Boolean algebra, also changed into the switching algebra. So the question is, what is the other name of Boolean algebra? It is also called switching algebra. So thus we know this Boolean algebra deals with the theory of logic, formal logic, as given by Aristotle, and later it was improved by George Boole, why it is called Boolean algebra, and later it's also called switching algebra because of the work done by Claude Shannon. Now we shall discuss binary valued quantities, variables and constants in Boolean algebra. Now let us ask some questions. Should I carry the book or not? Should I use a mobile phone or not? Should I miss the TV program today? All the above questions I have asked, they require the answers either yes or no. Understood? These are the only possible two answers for the above questions. For example, if I ask you, are you hungry or not? You may either say yes or no. That means these kind of questions are to say simply these type of statements will be always having one of the two answers, either yes or no. That is why these statements are called binary decisions or binary statements. Thus, a variable or a value used in Boolean algebra or a Boolean expression or equation can have only one among the two possible values. These two values are either true or false. True is denoted using 1 and false is denoted using 0. Now, the sentences which can be determined to be either true or false are called logical statements, or these are also called truth functions. and the results true or false. These are called truth values. So we have two terms here: truth functions, which are the logical statements, and the truth values, which will be the outcome or the result of these statements. Logical constants are true and false. As I told, they are 1 and 0 respectively, represented in Boolean algebra. The variables which can store these truth values are called logical variables or binary valued variables. Now, a decision that results in either true, yes, or false, 0, is called a binary decision. Then we will find out what are logical operators. These logical operators, as I told, they correspond to three basic logical operations. These are not, or, and. Generally, in expressions, we have operands and operators, as you know, in algebra. In Boolean algebra, the logical statements or truth functions are combined using logical operators, and, or, and not. These are called the basic or fundamental logical operators. We form a compound statement or a logical function by making use of logical variables, logical constants, and these logical operators. Let us find out some examples of logical operations or expressions. X not y, X or y, A and B. If you write like this one, all these are the examples of logical operations. Now, there is a term called truth table. A truth table is a table which represents all the possible values of a logical variable or statement along with all the possible results for those combinations of inputs. For example, if X and Y are the two logical statements, X can be either true or false, Y also can be either true or false. That is why there are four combinations of inputs. Either X is false, Y is also false, X is false, Y is true, X is true, Y is false, and both X and Y are true. So we will get four combinations. If you write the corresponding output for an operation for all these four combinations, what we are getting is a truth table. After knowing what is a truth table, which is a combination of various input values and the corresponding outputs shown as a table. Now, there is a possibility that the result of all the combinations of inputs in a truth table is always high or true. This condition is called a tautology. And another condition, when the output of a truth table is always 0 or false, whatever is the combinations of input values, then this condition is called fallacy. So normally we see two conditions like tautology and fallacy in truth tables. Next. Now let us see some basic operations. The not operator. The not operator operates on a single variable and the operation is performed is the complementation of the input signal. So we denote using an over bar over the variable name. Thus the complement operations can be defined as complement of 0 is 1 and complement of 1 is 0. As we are having only two values in Boolean algebra, 0 and 1. 1 and 0 are the complements of each other. Or in other words, not of false is true and not of true is false. The truth table for that is having only one input, which is X, having two possible values, 0 and 1. And the output for this one is denoted using X bar given by the values 1 and 0 respectively. The symbol, a tilde symbol or an over bar or apostrophe for the variable name can be used to denote the not operation. The next operation is OR, which uses the OR operator. This OR is also called the logical addition and the symbol used is plus. Thus, logical operation addition is X plus Y, means it is the logical addition of two variable values. It is also given using a TT like minimum 2 input variables x and y. We have 4 combinations 0 0, 0 1, 1 0 and 1 1. You'll be getting the output of an OR operator high when any one of the inputs are high. So for 4 combinations in series, we'll be getting the output as 0 1 1 1. So OR operation denotes that the output will be high when at least one input is high. Next, the AND operator, which denotes the AND operation, and it is the logical multiplication of the inputs. Now x dot y or x and y, the output will be, the output is high only when both the inputs are high. So for the 4 possible combinations of 2 input AND operation, 0 0 will get a 0 output, 0 1 also will be getting 0, 1 0 also 0, but for the last combination 1 and 1, when both the inputs are 1 each, then only we are getting high or 1 output. Next section is the evaluation of Boolean expressions using TT. Now, as we know, logical variables are combined by means of logical operators AND, OR and NOT to form Boolean expressions. It is convenient to shorten the expressions sometimes. And also, to construct logic circuits, we need to analyze Boolean expressions. So this truth table is one of the methods of analyzing the Boolean expressions or proving some Boolean algebra theorems. The variables used in the expression are to be evaluated for the given constant values of true and false as given or as required. Then we know how to construct the truth tables for 3 variables, 4 variables that we anyway are going to see in the exercises. Thank you.